A robotic spacecraft with a mechanical arm just grabbed a dead satellite in orbit and brought it back to life, turning what used to be a billion-dollar piece of space junk into an asset worth hundreds of millions more. And this single act may mark the beginning of the end of humanity's most expensive garbage dump. Right now, there are thousands of satellites circling Earth that are perfectly functional except for one problem. They have run out of fuel. When a communications satellite in geostationary orbit depletes its propellant, it can no longer maintain its precise position or orientation. Operators are forced to move it into a graveyard orbit or let it drift, even though its expensive instruments and solar arrays may still have years of life left. The global value of this stranded hardware is estimated in the hundreds of billions of dollars. Every year, more satellites join this orbital cemetery because there has never been a practical way to refuel or reposition them. That reality is now changing. In 2020 and 2021, Northrop Grumman's Mission Extension Vehicle, MEV, successfully docked with two commercial communications satellites, Intelsat 901 and Intelsat 10-02, that had run out of fuel. Using a robotic arm and a specially designed docking mechanism, the MEV attached itself to the exhausted satellite and used its own propulsion system to keep the combined spacecraft in the correct orbital slot. Both missions extended the satellite's operational lives by several additional years, proving that on-orbit servicing of satellites not originally designed to be serviced is not only possible, but commercially viable. Building on this success, companies like Astroscale are pushing the technology further. Astroscale has already demonstrated rendezvous, proximity operations, and capture techniques in orbit. Their ELSA-D mission in 2021 successfully captured a mock debris target using a magnetic docking plate. The company is now developing both satellite life extension services and active debris removal spacecraft, aiming to tackle both the stranded asset problem and the growing space debris crisis simultaneously. At the government level, NASA's OSAM-1 mission, On-Orbit Servicing, Assembly, and Manufacturing 1, represents the most ambitious robotic servicing project to date. Originally designed to rendezvous with the Landsat 7 Earth observation satellite, physically grab it, and refuel it through its existing fuel valve, OSAM-1 is a technology demonstrator meant to prove that a robotic spacecraft can service satellites never built with docking ports in mind. Although the program has faced significant cost overruns and schedule delays, it remains a cornerstone of NASA's plan to create a sustainable servicing infrastructure in Earth orbit. The economic implications are enormous. Building and launching a large communications satellite typically costs between $200 million and $500 million. Extending its life by even 3 to 5 years through robotic servicing can generate hundreds of millions in additional revenue while avoiding the cost of building and launching a replacement. If on-orbit servicing becomes routine, insurance models, satellite design philosophies, and entire business cases for orbital infrastructure will shift dramatically. Satellites may one day be built like cars, designed from the beginning to be maintained, upgraded, and kept operational for decades instead of being disposable after 5 to 15 years. We are watching the birth of a new orbital economy. Instead of abandoning hardware when it runs out of fuel, we will repair, refuel, reposition, and reuse it. The graveyard of dead satellites that currently surrounds Earth may eventually become a network of serviced, upgraded platforms, supporting everything from global broadband to Earth observation and national security. The age of throwaway satellites is ending. The age of orbital maintenance has begun. So here is the question I want you to answer in the comments. If robotic spacecraft can now repair and refuel satellites worth hundreds of millions of dollars, do you think this technology will primarily be used to extend the life of commercial satellites for profit? Or will it become essential infrastructure that governments use to protect national security and scientific assets in orbit? Follow this page right now if you want to stay ahead of the technologies that are quietly rewriting the rules of space, because the shift from disposable to repairable orbital infrastructure is one of the most important transitions happening above our heads, and we cover every major milestone as it occurs.